Alright, so far we've taken the factory settings. We've used avrdude to scan our chip, see what our factory settings are. Got a set of hexadecimal digits for the extended fuse, the low fuse, and the high fuse. And here we have what we're working on with the high fuse, and analyzed, saw what the settings are. So now we're going to reverse it. We're going to create our own byte with the settings we want, and then we're going to convert it to a hexadecimal number, and then program that hex number into our chip to change the settings. To keep, for simplicity's sake, I'm just going to change one setting, the J tag. Instead of having it enabled, I'm going to disable it because I think it gives me problems in port C when I've done some of my projects. I'm not sure, but apparently it does. So I'm going to play around with that and disable it. But that'll be the only bit I'm going to change, and it'll only be in the high byte. So we're going to take we're going to keep the same, basically the same byte, except okay, bit 7 is going to stay the same, and the JTAG bit 6 we're going to change from a 0 to a 1, and everything else is going to stay exactly the same as it was. Alright, so now we're going to take this byte, this new custom byte we just created for the high fuse, and going to convert it to a hex number. So I'll take the highest bit here, start over here. I'm just going to copy it. 1101, 1101, and then 1001. Alright, so let's convert it. 2 cubed is 8. And we got a 1 under 2 squared. So we're going to add 4 to the 8. Nothing in this column. And we're going to use the 2 to the 0, which is 1. Over here, basically stay the same. So what we had from the factory bit. 2 cubes 8, the 0 zeros here, and then we'll be using 2 to the 0, which is 1. So we'll add a 1. So that stays 9 like before, and this one's 13. But remember, hexadecimal is like base 16, I guess, and so it's 0 through 9, 0, 1, 2, 3, 4, up to 9, then A, B, C, D, E, F. And we got 13, so just count up 0, 1, 2, 3, up to 9, and then 10, 11, 12, 13. So it's going to be a D in hex. It's going to be D9 is our new custom byte that we're going to program into our high byte. Is going to be D9. And usually I'll use embedded AVR fuse calculator. You can Google it. It's pretty cool. I use it to back up my calculations. So I'll try to find my chip on here. There it is, ATmega 324 Papa, and it basically it'll calculate what we've already been doing is calculate the bytes for us, and let me see. Now you can see the fuse calculator is a little different than what we got. You can see that the high byte and the extended byte are the same, 99 and FF, and here they've got 42. So I'll leave it for homework. You can figure out what's different yourself. Maybe they selected a different startup time. But anyways, with this fuse calculator, you can check off the things you want to do. Basically, what we were doing over here by putting enabling or disabling. Either check the box or uncheck it, and then it'll give you a little readout down here at the bottom. And then just use that. I just use that to back up my calculations, make sure that when I converted my bytes to hex, I didn't screw something up. And also gives you a nice little format that you can use to enter in your command line for your avrdude. You can double check that too as well. So so now we've got our byte, and now we're going to program it. And let me see. Alright, so basically we're going to enter the same line we did up here, except dropping the verbose commands, and then we're going to replace them basically with our write command. And you can see here I've got a 7F. That was when I was doing the crystal, putting the crystal in my circuit, and I was changing the the setting for to use a crystal, and also the startup time for the crystal. So obviously we got a different number because what we're doing here, we're just going to be changing and disabling the J tag. So obviously we're going to have a different number than what I have here. But basically this is all going to be the same. I'm going to use the capital U, and then of course we'll change our instead of our low fuse, we'll use our high fuse, and then our W is to write to our chip, and then you put your colon with your hex number, and then a colon and an M, and I still don't know what the hell the M is. I think it's the format. So you can we'll look up the U here. If you don't know what some of these letters mean, or you forgot them, you can type in avrdude. And it helps if I take the cap locks off. Alright, forgot a hyphen. So if you can't remember what the letters are, just type in avrdude space dash or hyphen, whatever, and question mark, and then you'll get your definitions. So over here we're going to be using the dash U or hyphen U, and that'll be the memory type, whether it's going to be a read, a write, or I forgot what the V was. Or I guess verify in this case. And so anyways, so basically we're going to take, like I said, what we had before when we're trying to get the output. So the avrdude, our type of programmer, the chip we're programming, the port it's on, then dash U for the type, the memory type we're going to be doing. In this case we're going to be writing. It'll be the high fuse, and then it'll be that hex number. So alright, so we're going to type out exactly what we did before, except for the two V's, verbose, avrdude space dash C space avrisp v2 space dash pm324 p space and dash cap uppercase pcom4, and then you can use your little calculator program here to get your format right. So we're going to go dash capital U and then a colon, so you can see over here. the colon, then the W, lowercase w for write. It means we're going to be serious here. We're actually going to try and screw this chip up. Another colon, and then we're going to put in our custom bit that we figured out before, our D9 for our high fuse. Alright, make sure I don't screw this up. Alright, so it's going to be a hex number, so it's 0x, not OX. It's always a 0. Took me a while to learn that. And I will once again double and triple check my lousy memory. So we're going to write D9. And then another colon and lowercase m. Alright, so let's see what is wrong with this picture. I forgot something, didn't I? Alright, which fuse I'm going to program after the U. Going to be the high fuse. Double check it. So we've got a dash U, a space, then H fuse for high fuse, and a colon, W for write, colon, hex D9, colon, and then M. Alright, so got my programmer hooked up. And it's verified 1 byte, high fuse verified. So to check if, to double check, you can always use your, arrow on your keyboard to bring up your last command line that you typed. And basically just going to erase that and then put back our verbose settings just so we can read our chip again and see if our settings went in. Alright, so you can see here we've got the D9. The other bytes stayed the same, the extended byte and the extended fuse and the low fuse stayed the same, and we changed our high fuse. So basically I'm running out of time, so that's it. Have fun.